All right. Once again, welcome everyone. I am Karan Malhi, and I'm a product manager at StreamNative. We also have two more panelists. We have Kundan and Dustin. Dustin, why don't you introduce yourself?
Sure. My name is Dustin Nest. I work in training and enablement here at StreamNative. Before I hand it back or over to Kundan, I'm going to make a plug. Later in the webinar, I'm going to be doing a demo. The demo will feature two of the key features that we're going to talk about in the product roadmap. One is a demo of the self-service bring your own cloud feature in our UI. And then I'll also be showing our Lakehouse storage to Iceberg using Tabular towards the end of the webinar as well. So stick around for those two. But I think next we're going to hand it over to Kundan for his introduction.
Yeah, hi, thanks, Dustin. Hello, everyone. I'm Kundan Vyas. I'm part of the product team here at StreamNative. It's been a few months. I'm with the company, so I'm really excited to share our product roadmap and vision. Yeah, so looking forward to this whole session today. Let me hand it over to Karan.
All right. Thank you, Dustin and Kundan. I am Karan Malhi, product manager in the past, Apache committer, developer, trainer, and so on. Mainly worked on developer tooling and products like that. Right. So just an FYI, this webinar is being recorded. We will share the recording with you after the webinar is over, so you should check your email. Let's start off. So Kundan, can you just move the slide? Okay. So let's look at the agenda. We are going to go through StreamNative Roadmap. We are going to introduce you to the Ursa engine, followed by some deployment updates by Kundan, and then a demo by Dustin. Okay, so quickly about StreamNative. StreamNative, we are the enterprise data streaming and messaging company. We are the company behind Apache Pulsar. As you know, Apache has contributed some really great projects in the ecosystem, and there's tons of businesses running around Apache. So we are also one of the big contributors to Apache, and especially around data streaming and messaging with Apache Pulsar. Okay, I want to start off this this webinar with the CAP theorem. CAP theorem is also called as Brewer's theorem. It is around distributed databases or distributed data. And the theorem is anchored around three pillars. The original theorem by Brewer is around consistency, availability, and partition tolerance. But we believe that for the new distributed data ecosystem or distributed streaming ecosystem, the CAP theorem needs to be revised, where we need to look at cost, performance, and availability. So a lot of times people create or build distributed systems or have distributed architectures, but they're not able to reason about things. So I want to kind of point your attention to this slide, where you should be able to reason about your initiatives, your architecture, or your technical decisions based on these three things. So if you look at Apache Pulsar and StreamNative, originally it was a AP system, availability and performance system. Okay, then so you could do data streaming and messaging across multiple AZs. There's high availability, high performance, unlimited scalability. We then also came with the performance and cost. We also can operate as a PC system, performance and cost system, where you can operate StreamNative on a single AZ. Okay, and then we thought about it and we said, okay, can we further reduce the cost while maintaining high availability? So could we also be a CA system? Okay, and I want you to keep this in mind as we go through the rest of the slides. Next slide. Okay, a brief reminder of the architectural eras. Okay, this will help me explain the Ursa engine, which I'm going to talk about briefly. So if you think about the architectural eras, I mean, I'm old. I worked in the early 2000s, late 90s. You had the on-prem era, where you had compute and storage together. You could throw a big box and treat it like a pet, and you could have unlimited scalability, literally high performance. But availability was not that high. Then people started moving towards high availability. The world got more connected. You got Facebook and social media, and the demands of the world was we need the systems always on. And we came into the cloud native era with unlimited elasticity. Now, however, we are in the hybrid era. We take elasticity for granted. We take high availability for granted. And we take always on for granted and performance for granted. But that comes at a cost of cost. So it's costly. So people now are moving towards this hybrid era where they're looking at storage technology, because data and network are two of the costly pieces in such architectures. And they're trying to look at not just data in terms of cost, but also data in terms of standardization. Okay, so keep this in mind, keep cost, availability, performance in mind, keep these architectural errors in mind, okay? Because now in the next slide, I'm going to talk about the cloud native era and talk about data streaming and messaging there. Next slide. So if you look at just the cloud native era and Pulsar, Apache Pulsar, there's one big event which happened in 2015, which was Kubernetes 1.0 was released. So prior to that, we had Kafka, beautiful system, okay, which was released, but it was released more on the on-prem era, in the Hadoop era. So compute and storage was together. Kubernetes came out and said, we can separate those. You can have unlimited elasticity. And Apache Pulsar, which was brewing it at Yahoo, an enterprise scale company, was built for the cloud native era. And because it was built for the cloud native era, it looked at both messaging and streaming and storage to be built in such a way that there was unlimited scalability and elasticity. So that's an important thing to consider. That is why we believe that Apache Pulsar and the StreamNative platform can give you the dials to work around cost, availability, and performance, because we are purpose-built for Kubernetes. Next slide. Okay, so what is the Kafka problem today? When we talk about elasticity, because Kafka was built in the on-prem era, rightly so at that time, taking the right decisions to solve the problems at that time, compute and storage are co-located. You had to build for rack awareness. You had to optimize for that. You had to. Kafka was also had this partition-based storage model, which required repartitioning and rebalancing. In fact, I did not realize until I went to a meetup recently, where somebody was talking about a big, huge payments company, consumer payments company, was talking about having 4,000 bare metal nodes of Kafka. Each node was around 23 terabytes of storage, and repartitioning would take hours, sometimes even 24 hours. Okay, so that's the extent of the problem which Kafka has right now. And the result of that is, can you put the next slide? The result of that is cost. Okay, so you have infrastructure costs, you have operational costs, you have integration costs. Okay, over provisioning in the infrastructure is a thing. Your cross-AZ network costs are big, okay? And your long-term storage data is very, very expensive. Okay? Operationally, capacity planning and scaling of clusters is really hard. I personally have provisioned a Kafka clusters across 9 AWS regions. I was a product manager for the infrastructure, and for at least a year, we were using less than 5% of the capacity because we had to over provision for a product we were building. Okay, and then there is integration costs. You have you in the data world today, you are processing and reprocessing data, and that could travel over the network, that could travel over different storage systems. So it just becomes very expensive to have a system where compute and storage are co-located. Next slide. So how do we reduce costs? What if I had a system where I could reduce or even eliminate any cross-AZ traffic? Networking is very expensive. What if I had a system where I could remove all the keepers, all the ZooKeeper or any other component, and just unify the system into one? What if I had a system where I could take my existing Kafka investments to use that system, which means if I've written hundreds of applications, hundreds of services with Kafka clients, I could just plug those into this new system and it just works. It takes all the elasticity into consideration, and suddenly you get transformed from a compute plus storage model to a separate compute storage and an elastic model. And what if I had a system where I could take my existing data and make it available in a format which was standardized, like the open table format, and reduce any bespoke integration? Okay. So if I could do this, then I could take my existing Kafka investments and just plug that to a new system. And that new system is what we'll show the next slide. Can you show the next slide? So that new system is Ursa. And Ursa is a StreamNative's engine, which is underneath the StreamNative platform. Okay. And if you look at the bigger blocks of Ursa, you have support for multiple protocols. So we support both Kafka API and the Pulsar API. It supports both streaming and messaging, which is huge for enterprise systems. Okay. We have stateless brokers. Ursa has stateless brokers in the sense that there's unlimited scalability. We leverage the underlying Kubernetes system, and the brokers can be a mix of cost optimized, which means you can use a cost optimized write-ahead log, or they're latency optimized, which means you can have a very low latency BookKeeper based write-ahead log. And beneath that, you can plug in an open table format based Lakehouse, or even table formatted streams. So it's something which Kundan's going to talk about. So if you think about Ursa as an enterprise system, you bring that into your infrastructure. You have support for both streaming and messaging, support for a Kubernetes native platform for streaming and messaging, and you have support for a write-ahead log, which is huge in the data streaming world. Next slide. So talking about Ursa, our roadmap is very much around the costs. And you can see that we have divided the roadmap for this year, at least, into 4 phases. Earlier this year, we released a Kafka compatible API, which lowers your migration costs. So if you have Kafka investments, Kafka clients, okay, as I said earlier, just point them to Ursa and it'll just work. Okay. No rebalancing needed, no migration by rewriting apps needed. You can continue to use the whole Kafka ecosystem and connectors and so on. Okay. Then we have phase 2, 3, and 4, which is more about lowering storage costs, management costs by removing keepers, and then just getting your data ready or AI ready data. Okay. And Kundan's actually going to talk about these 3 phases with you next. So Kundan, over to you.
Awesome. Thank you so much, Karan. So you heard about Ursa, and I want to walk you through the different phases of the Ursa roadmap. So phase 1, you heard from Karan, we launched the Kafka compatible API. So let's talk about phase 2 and beyond. So in phase 2, our focus has been primarily around Lakehouse storage support, right? Let's get into that. So Lakehouses have been popular for a while now. And I think back in November 2023, StreamNative saw this really as a vision that I think customers, most enterprises are going to need an ability to integrate with these different types of Lakehouse formats as they are starting to evolve. So we basically announced a vision behind our product integration with these Lakehouses back in November 2023. Basically, it's pretty straightforward and simple. Within StreamNative Cloud, we'll provide an out-of-the-box capability for you to integrate with different Lakehouses. You come into the cloud and you just enable the Lakehouse storage, and you can leverage a capability which will basically offload your data to a low-cost storage service of your choice, like S3, Google Cloud Storage, or Azure Blob Storage, in a format, an open Lakehouse format of your choice. So right now we support Delta Lake and Apache Iceberg, and we're going to support Apache Hudi in the future, right? The key thing here is that there are 2 different primary use cases which are very much possible here. One is that once the data is stored in an offloaded state, your consumers can continue to read that from your topic, and we will actually pull that data from the offloaded state and bring it and present it to you, right? So that's the streaming read use case. The second use case is where a lot of customers want to store that data in offloaded state in open format, so they can query it using third-party tools like Amazon Athena, right? So that's very much possible too. So both these use cases are supported in this sort of approach. You don't have to write any integration. I think Karan spoke briefly about our focus being in lowering so many different types of operational costs, and integration cost is one of them. Ideally, you have to set up a pipeline, a connector to kind of move data between these lake houses and your event streaming platform. So you don't have to do that here. It's out of the box, and it's very customizable, right? So it's in public preview right now. You can definitely try it out, sign up for a trial. I'll show you more details how to sign up for a trial. So let's look at a couple of examples of the Lakehouse Storage Integration, right? I'm just using the context of Databricks to talk about the Delta Lake support. As you come into StreamNative Cloud, you can basically enable Lakehouse Storage, and you can say, I want this data to get offloaded in a Delta Lake format. Once the data goes and sits in a low-cost storage of your choice, something like, let's say, S3, you then can, if you are using, I'm just using the example of Databricks here, if you come in as a Databricks customer, you can basically mount that data in Databricks as an external table by pointing to an external storage location. Once the data is within their Unity catalog, then I think you can easily process that data through their SQL tools or different types of jobs which you can run there, right? So that's a little bit about Delta Lake support. Similar example here for our Iceberg support. I'm using the example of Tabular integration. Tabular is now acquired by Databricks. So they are actually one of the founders or the creators of the Apache Iceberg format, and perhaps also the contributor to the REST catalog interface, right? So the options here for our customers is, again, something pretty straightforward. Within StreamNative Cloud, you would come in and enable your Lakehouse storage and say that I want this data to get offloaded in the Iceberg table format. That data will go sit in your low-cost storage. Now here you have actually two options. You can either just store it in Iceberg format and use your third-party tools to kind of talk to it. Or actually, if you want to integrate with a REST catalog, in this case, I'm using the example of Tabular, you can do that as well. There are lots of advantages with a REST catalog typically offers if you want to integrate your Lakehouse storages with that. So in this case, the way this typically works is StreamNative would do all the metadata interactions through Tabular. And with the metadata interactions, I mean, creating table, updating table, those kind of things, right? So all that happens through Tabular's REST catalog. And then for a direct data transfer, we still use REST catalog's data API, but we write the data directly, right? So that's a little bit about how this would work with Tabular. So let me continue to move on. So one thing to highlight here before I forget, I think Dustin is going to cover this in our demo today. So you'll get to see this live in action, our integration of Lakehouse Storage with Tabular's REST catalog. Okay, so hold on for it. It's right at the end. All right, so let's move on to the next phase. In this phase, our focus really moved towards improving our architecture. How do we tweak our architecture? How do we focus on the areas which need improvements so that we can lower the management costs? And at that time, our attention went to ZooKeeper. So ZooKeeper is one of the components we use within our architectures to store metadata. When you come into StreamNative Cloud and create different types of objects, like let's say topics or other things, there is a lot of metadata which gets generated. You typically need a place to store that metadata, right? And ZooKeeper does that job for us today. And over time, as your data grows, your metadata also grows. So one of the challenges with ZooKeeper has been that it's been really hard to scale, right? Also, it's pretty hard to manage storage associated with it when it grows. So we are replacing ZooKeeper with the alternative, which is a more efficient cloud-native application, which is designed to scale well and run on something like Kubernetes, right? And this is called Oxia. Oxia is a contribution from StreamNative. It's open sourced, but this is going to now allow us to scale very easily and support large amounts of metadata. So as a result of that, for end users, what this means is they can have hundreds and thousands of topics. without worrying about, the metadata crashing on it or things like that, right? A lot more other use cases there. So that's another improvement here we're focusing in this area. So that was phase 3. Phase 4 is pretty exciting. Lots of new enhancements here. So I'm going to start with the very first one. So let's talk about connectivity. So when we talk about enterprises, apart from and data infrastructure and data platform being really a big part of the discussion. So apart from maintaining and scaling the data infrastructure and all the all the operations around it, one of the challenges which enterprises also face is about connectivity. There is a huge surface area. There's a huge set of data sources typically any enterprise would want to connect to bring data in and out of their core data processing systems, right? So here with our new offering, what we are announcing is a very simple experience within StreamNative Cloud, which is going to allow customers to build streaming data pipelines. So you can come in, you can just use a very simple UI to either connect, process, debug, and monitor your pipelines, irrespective of the technology you're using underneath, whether it's Pulsar or Kafka-based connectors, it doesn't matter. What matters is you come in and you focus on creating your pipelines. You focus on quickly moving your data like in and out of StreamNative Cloud and moving it to the destination where you want to take it. Apart from just making it easier for you to connect to your data sources and create pipelines, we also provide a very lightweight approach to add some transformations to your data as that comes into StreamNative Cloud. And that's what we call functions. So with StreamNative functions, you can write some custom code in either Java, Python, or Go language, and which is going to basically just take your data and transform it the way you want and put it in a different location. So this example, what I'm showing here is just saying, I'm going to pull in a lot of data from different sources using a certain type of connector, store it in the topic, and then again, I would use a function, some sort of a code execution within as a function, which will transform that data and then store it in a different topic. And then I would use another connector to kind of push that out to the destination. Functions capability is optional. You don't always have to use it. A lot of customers prefer actually processing the data only downstream after that's being pushed. But this is still an optional for customers who want to do some transformations here, right? So we have a growing list of fully managed connectors in StreamNative Cloud, which will span across Kafka and Pulsar. So customers, again, can choose. But again, as I said, I would recommend that the vision behind this is that we will give an experience to our users that they don't have to worry about what sort of connectivity option they're using. They focus on just building the pipeline and moving the data, right? So that's something which is a big part of focus for this new experience, which we're calling the unified connectivity in StreamNative Cloud, okay? So let's move on, talk a little more about some of the other enhancements coming in phase 4. So Karan spoke about the overall vision behind Ursa. I think he also covered some components of it. So just to touch on the areas related to the storage, right? So we have two categories of customers, at least that's what we see in the industry who want to move data quickly to their destination. One of the first set of customers are the ones who want to actually who need absolutely no latency, like literally in the matter of micro or nano milliseconds. They want to push the data the moment it comes. The second set of customers are the ones who are okay with a little bit of latency, right? So I think for the second category, we're introducing a new way in which you can move data directly to an object store. As the data comes in to StreamNative Cloud, from the broker, we push it directly to a low-cost storage of your choice. That way, I think you can save a lot of storage costs for that data, which you have some flexibility to move, right? So that's one. And then, of course, for the customers who have a specific requirements around latency, I think we continue to keep the option of BookKeeper. So Apache BookKeeper is the layer within our infrastructure which stores the data, and that's the storage layer, and that's something which will continue to keep as an option. So again, experience-wise, the way I'm trying to describe it is like when you come into StreamNative Cloud, you will have a choice of configuring these storage layers and how you want to move your data and store your data based on the type of quality of service requirements you have, right? So that's critical. Now let's talk about network improvements, right? I think Karan briefly covered this as well. But essentially, apart from storage, one of the big areas where customers face a lot of challenge and incur a lot of costs is the cross-regional data transfer costs. So as your data moves from one region to another region, oftentimes there's a lot of cost associated with it. And within the cloud, within StreamNative Cloud, typically there are different situations where for high availability reasons, we had to maintain different copies of the data, right? But we are now introducing a new option where the customers can, like when they use the write-ahead log option with the object storage, where you can stream data directly to an object storage, you can completely get rid of the cross availability zone network traffic, right? With that, actually, over time, if you think about the petabytes of data or how much of data you are moving, you can actually calculate how much cost you will save if you switch to this sort of a model, right? So again, this would be helpful for customers who are not very critical, like latency is not as critical for them. I think they can definitely choose and switch to this option, right? So, so that was a little bit on phase 4. And just to quickly summarize, I also want to do a time check. How do I am doing on the time? Looks like we're doing okay. These are the 4 different phases of the Ursa roadmap, right? Again, I hope you take advantage of this, because if you really think of the total cost of ownership of your of your infrastructure, I think these are different areas where you can leverage these capabilities to lower your costs, right? Now let's move on to the next roadmap, which is the roadmap about our deployment options. So Ursa was the engine, the new engine which we have underneath the platform, as Karan mentioned. And what I'm about to talk about is basically different ways in which you can deploy StreamNative Cloud, right? StreamNative Cloud is available as like primarily 3 different offerings. We have the hosted and the bring your own cloud offering, which are our fully managed offerings. And we have the private cloud, which is more of a hybrid cloud setup, right? So some of these roadmap items which you'll see here are related to these categories of deployments. So let me start with phase 1, actually, where we announced our product on Azure. So StreamNative Cloud is GA and Azure, like we went GA in Q1. With that, basically now we are available for our customers in AWS, Google Cloud, and Azure, right? And in phase 2, now we are launching a self-service experience to basically provision the infrastructure for BYOC, right? And let me just walk you through some more details around it. So bring your own cloud offering is of StreamNative is something which runs in a customer's cloud account, right? There are lots of benefits of doing that, but essentially it's still fully managed by StreamNative, but it is running in customer's account, right? And we've had this capability out for a while now, and we've had an ability to provision this using, APIs and command line interface and Terraform, right? But now we're launching this user experience. A lot of times this comes handy when you're really trying to move faster and try out things, right? So to talk about this whole user experience, which is more of a self-service type of experience to provision the infrastructure for your bring your own cloud account, it's basically just 3 steps. The first step is really about granting access to StreamNative. It's called the vendor access, which a customer would grant to the SaaS provider. So since Bring Your Own Cloud is a fully managed offering, StreamNative needs to get a certain type of access to that deployment. And that's done by sort of running some Terraform modules on the customer's end, right? Once you do that, then I think step 2 and 3 is more about establishing connectivity and sort of creating the environment, right? And once these 3 steps are done, basically now this is a one-time job, this step 1, 2, and 3, and then you're ready to basically create your instances and clusters within your StreamNative Cloud BYOC offering, right? So what you're seeing 1, 2, and 3 here has been possible through API, through command line, through Terraform, and now we are going to offer this capability through a user experience. Now, you're going to see this in demo today. Dustin is going to cover this at the end of, like right at the end of the third part of this webcast. and you'll see this in action. Just one or two things very quickly to just to make the experience better for the users. As you start provisioning your BYOC environment, you basically we notify the user at different stages. When the provisioning is in progress, we send out the first email, and when the provisioning is complete, the user gets the second email. So yeah, so just to again bring back to what I was saying, we've had the ability to provision this infrastructure setup from API, Terraform, and command line. And with adding this UI, this really completes our story. And we are now offering a multi-interface experience for our customers to really access a way to set up that infrastructure, right? Okay, so now let's move on quickly to phase 3 and phase 4. And then I want to hand it over to Dustin for the demos, right? So phase 3, again, continuing on that journey, we're basically aiming to get our product on Azure Marketplace. So our product is now already available on AWS Marketplace and Google Cloud Marketplace. So with Azure Marketplace now, this whole story will be complete. And there are lots of advantages of having an access to a product through a cloud service provider's marketplace, because as a customer, as an enterprise, your billing is well integrated into the cloud service provider's billing and so many other advantages. So this is coming soon as well. Let's talk about phase 4. Phase 4 is something where end of the year, we're planning something really exciting. And this is basically the StreamNative serverless offering. Now, I'm just going to share just one or two things about it. It's in Q4, and we are really excited about it because all the improvements we're doing in our core engine, which we call Ursa, which will give us all the benefits which we want to give away to our customers. That is also driving this offer, which means that with this offering, we'll be able to offer complete flexibility to our customers of how and when they provision and basically run the StreamNative Cloud product, right? So think of this offering as a completely headless, serverless, sort of way to access a service. You can scale in and out when you need it, pay only what you use, and you have utmost control and flexibility of when you can opt in and out of it, right? So I think there's no upfront commitment, and particularly around infrastructure, there's no setup or anything required. It's ready to go, ready to use, right? So this is really exciting. We are looking forward to this announcement coming up in Q4. So just this is just giving you some visibility in what's coming in the future. All right. So I think we spoke about a lot of things today. If you want to really try out StreamNative Cloud, you can actually sign up for a trial. The trial does not have any specific duration, 30-day or 60-day. As long as your $200, which we give you free last, you can use them. You can scan this barcode to actually get routed to a sign-up page, and then you'll have your environment ready in no time, right? So try this out. Also, if you want to book a demo, you can use that link. So I'm going to put this in here just for 5 seconds if you want to take a picture of this barcode and try that out. All right. So that was all the stuff on the roadmap, Ursa roadmap, and the deployment roadmap. Now I want to hand it over to Dustin, who's going to walk us through an exciting demo. Dustin, over to you. I'm going to stop sharing so you can share.
Sounds good. Let me share my desktop here. So I'm going to be demoing 2 things today. The first thing is the self-service BYOC deployment. I'm going to focus on the deployment of the cloud connection and the cloud environment. The actual deployment of the Pulsar cluster is pretty much the same whether you're on hosted or BYOC. And then second, I'm going to show what it looks like to use the Lakehouse storage in Iceberg format with Tabular. So first off, just to introduce you to the UI, this is the StreamNative UI. I've deployed a few clusters already, and I actually already have some BYOC resources deployed. So here I have a cluster. Here you can see it's BYOC, where I have the Iceberg set up for the demo that's going to be next. But if you had no clusters here, you'd basically have a button here that would say, create your first cluster. And what's going to end up showing is you're going to get the option to say deploy BYOC. When you click on that, it's going to say you don't have any cloud connections yet. You don't have any cloud environments yet. You don't have any of the underlying resources that you need to deploy a BYOC Pulsar cluster. I already have some of those resources, so my order of operations here is going to be a little bit different. So instead of deploying through this workflow, I'm going to actually show you where you can see your existing connections and your environments, and I'm going to deploy a new environment. So to see those existing connections, or the existing connection and the environments that are underlying these two BYOC clusters, actually, just a little caveat here. I have two BYOC clusters that each have their own underlying resources that are segregated, but I could alternately have also put them inside of one EKS cluster, inside of one cloud environment. That's up to you. That option is available for you. So if I go up here to the upper right, I can go to the Cloud Environments tab. If I go to Cloud Connections, this is my connection into my AWS account. And when I say my AWS account, it's the one I use in training that is separate from all the other accounts that are where production runs for StreamNative. It's essentially as though I'm a customer where I have an AWS account. Now, if I wanted to create a new connection, I would say create connection. And this is where you make a name for the connection. You choose your connection provider. Right now, we only support AWS for BYOC, but Google Cloud and Azure are going to be coming very soon. You specify your AWS account, and then you have to confirm that you ran the vendor access Terraform module. Now, Kundan had talked about this. This is the one part of the process that you can't do through the UI, because at this point, StreamNative can't connect to your cluster before you run that module. I do have a YouTube video on how to do that. It's very simple. It provides the exact permissions into your AWS account that StreamNative needs to then go through the rest of the process. Rest of the process meaning exactly what we're doing now, creating that first cloud connection, creating the cloud environment, and then deploying all those resources in the Pulsar cluster. So if I'm not going to create a new cloud connection because I already have a connection to my AWS account. But what it would do is it would reach out when I click submit here and create this cloud connection here. And at this point now, StreamNative's API server is able to connect to your AWS account. No resources are actually deployed yet. The permissions are there because you ran the access module. We've connected and verified that we can connect to your AWS account, but we haven't deployed anything yet. To actually deploy something, you deploy a cloud environment. I have two cloud environments deployed. I have one for each of my two BYOC clusters because I wanted them segregated, but you don't have to. Here's the names of those two cloud environments and the regions. I'm going to actually start the deployment of one during this call right now. If I go to create environment, first you have to click or select your cloud connection. What AWS environment do you want to deploy those resources to? You select a region. So I'm going to use US East 1. And I'll leave zonal off, but zonal here refers to, is it a multi-availability zone or a single zone? And this goes back to that CAP theorem. By having a single zone cloud environment, you're only going to be able to deploy single zone Pulsar clusters. And with that, you're going to get the cost versus performance optimization. You're basically leaving out, or it's less important for you to have the availability portion of the CAP theorem. I'm going to switch my tag here to test, leave the CIDR as is. I have those available CIDRs in that region. And then public or private gateway specifies whether or not when you do end up deploying Pulsar clusters into this cloud environment, are there endpoints available over the internet? And those are the endpoints for things like publishing Kafka messages, publishing Pulsar messages, administration endpoint. So if you put those to private, they're not going to be exposed over the internet, and they're only available within your AWS environment. I'm going to click create on this, and it's going to start the creation process. However, this process takes about 40 minutes. This is going to deploy your VPC, your subnets, your EKS cluster. This is specific to AWS, of course. Your node group, so that's your actual resources that run the Pulsar cluster. It's going to put in some of the metric server type things for StreamNative to be able to monitor your cluster, but it's not going to actually deploy the Pulsar cluster yet. So you're going to get the underlying infrastructure resources, but not the Pulsar cluster at this point. Let me go ahead and say go back here. You can say this one says creating. As it goes through this creation process, the status here is going to start updating what step it's on. And at this point, I should have already received that first email that Kundan was referring to, saying that these resources are deploying. When it's finished in about 40 minutes, at that point, that's when I would get that email that it's done. And then when I go back to the dashboard, when I go to the plus sign here to deploy a BYOC cluster, I'll just say instance, my cloud connection. Once that 40 minutes is up and the EKS cluster and all that is running, inside of my choices of where do I want to deploy my next BYOC Pulsar cluster, that will become an option, that new cloud environment. Right now, I can't even select it because it's still in the creation mode. So it's basically saying it's spinning up those resources, but there's nothing there yet for the Pulsar cluster to run on. So that's going to take about 40 minutes. We obviously don't have 40 minutes left in the webinar. So in order to be able to demo the next part, I had to spin up the Iceberg cluster ahead of time, or the cluster that I'm going to use for Iceberg. So that's the end of the first part of the demo, showing how you can create the cloud connection. And then I've started the deployment of the cloud environment into my AWS environment. Once those are done, again, then you would be able to spin up your Pulsar clusters. I have 2 of those here. We're going to be working on the Iceberg instance here. I'm going to select the Iceberg cluster. I have a tenant here, public, and I have a namespace called demo. And I have a topic in here called input topic where I'm publishing data to it right now. Just to show you what that data looks like, I have IntelliJ running here over on the side. I'm publishing, as you can see, the data to that tenant, namespace, and topic. It's an Avro schema here. I just have 2 fields on it. It's a name and a number. It's an age, but I'm just incrementing that so I can monitor about how many messages I've published. So as Kundan had mentioned, we're moving towards this cost savings idea of using Lakehouse storage. Now, just because I have enabled Iceberg for this particular topic, and in fact, you enable it at the namespace level, that doesn't mean I've enabled it for the whole cluster. So we're still giving you the option to continue to use BookKeeper long-term when you have those low latency applications. But for this particular namespace, I've enabled it so that all topics in this namespace will offload into Iceberg. If I go back over to my topic here, again, this is the input topic that I was just showing you I'm publishing the data to. You can see there's some input and output data. The offload process is currently running, and let me show you what that looks like over here in Tabular. Actually, let me go back to warehouses. Here I have different warehouses. This warehouse actually corresponds to the cluster that I had just shown you where Iceberg is set up. It's in the US West 2 region, which is actually the exact same region where I have that Pulsar cluster. So we don't have any inter-zone, actually inter-region traffic here. Because this is BYOC, I have the Pulsar cluster running in that region, and this S3 bucket that is storing the data in the Iceberg format is also in that same region. If I click on training, I get down to the database level. The databases correspond to a concatenation of your tenant and namespace. That's just the way that Tabular works, or Iceberg. They don't have the same number of levels that we have in Pulsar. So I have created a database called public demo that corresponds to my public demo tenant and namespace. You can see here that this topic is created called input topic. Now, if I go in here, I'll see the schema is registered as name and age. And then this is all metadata that Pulsar adds on to that. But the main thing I want to show you, I could do a data preview as well. You can start to see some of the data show up here with the name and the number incrementing. But over here on the activity, you can see that the data is actually offloaded into Tabular at approximately every 2 minutes. Now, very soon, as Kundan had mentioned in the roadmap, we're actually going to be removing the need for BookKeeper altogether in this data flow. So eventually, as the roadmap progresses, very soon we'll be able to, instead of first writing to BookKeeper and then offloading periodically, here it's every 2 minutes, into Iceberg, it's going to be a direct write into Iceberg for the data that does not require low latency. So again, you can select that at the different namespace levels. I think that's all I had. Kundan or Karan, is there anything else that I missed? I think I got the 2 main parts of the demo. We got the BYOC. We're showing the data live offloading into Iceberg as well. And we're gonna soon, I'm gonna release 2 YouTube videos on these exact demos very shortly. And of course, you can always rewatch the webinar as well.
Perfect. Dustin, thank you so much. Okay, I'm going to share my screen again just to move on. All right, so that was the demo. And let's move on now to the conclusion. Yeah.
All right. Thank you both, Kundan and Dustin. We also have some questions, but let me quickly summarize and then we go on to questions. So with Ursa, with StreamNative Ursa, you can reduce costs, slash your migration expenses, keep your Kafka clients, and you can still use Ursa, slash your management expenses, because we are moving towards a world where there are going to be no keepers, no ZooKeepers, no bookkeepers. Take your data and directly publish to Lakehouse. So no bespoke integrations needed. And then finally, deployment options, where you can come to us unhosted. So you can come to Ursa, or we can bring Ursa to you on if you have your own cloud, BYOC, or you can just take Ursa and put it in your private box somewhere. That's a private cloud option. And for the public cloud options, we are available on all 3 clouds, and we are moving towards that direction. Okay. All right. So that's the summary. Let me quickly jump. So Kundan, there are some questions. I'm going to read out the first question.
Sure.
First one was, and I kind of answered it in the chat itself. Would the cross AZ traffic savings include reads? From the slide, it looks like the savings are only applicable for writes. And in brackets, it's by avoiding writes to multiple bookies.
Yeah, no, I think it'll include reads. Perhaps I could use a better diagram there myself. But I think that should include reads as well. Yeah.
Okay. All right. The second question is, what does the migration process look like for existing clusters that would like to leverage direct writes to Lakehouse storage in the future?
Yeah, I think we are still figuring out some of the key steps around that, but I think I would still say that we will try to ensure we'll work with the customers to ensure that there is a like certain level of graceful transition planned by creating different environments. Like it's a combination of either creating environments for them so that we're hand-holding them and with reducing the downtime which they'll have to go through. We could also, from a capabilities side, I think it's going to be more of switching, and basically as we come to your cluster and upgrade it, I think there would be a very short time when we have to actually switch to some default configuration. So we'll educate you that, hey, as we switch and upgrade and migrate you to some of these new architectures based on Ursa, this is what we will set as a default. But if you want to switch to something else, perhaps we give that as a choice. So I think we'll educate you on what the defaults are and what you want to switch to. So that's what all I can think of at this point of time. And then we'll work closely with you to ensure we understand your timelines and when you want to actually do it. So we give you some flexibility around, having a little longer time to upgrade and things like that.
Kundan, do you think it would help if I also explain a little bit about the process that it took for me to get the Iceberg cluster up and running for the
That'll
demo?
be awesome. That'll be awesome.
So because I assume it's not going to be too different when it becomes a direct write. So to get the Iceberg cluster up and running for the demo, basically I went into Tabular and created a link to my S3 bucket. That really has nothing to do with StreamNative at that point. But to then have the Iceberg cluster write into that S3 bucket, StreamNative doesn't need to know anything about that S3 bucket. It actually needs information on the Tabular side. All I had to provide our engineering department was the warehouse name, which corresponded to the cluster that was called training, and then a credential, which is very easy to create in the Tabular UI. And they were able to turn it on in minutes. There was a broker restart, and that's about it. That process may become automated in the UI at some point, but basically that's all the cluster really needs to know about where the tabular service is. Once that's done, that doesn't mean your whole cluster immediately starts writing everything into Iceberg. That's that next step where we go through the process of which of the tenants and namespaces are the ones that you want to use this resource. And eventually that will become the which ones do you want to use direct writes and which ones do you want to skip BookKeeper altogether is what I'm presuming it will look like. That's what the current process looks like right now. And to do that right now, it's a very simple Pulsar admin command. All you do is tell it to write to Lakehouse Storage, and it starts that offload process.
All right,
Thanks,
thank you. We have a couple more questions. Is Lakehouse Storage support available on private cloud?
Yes, it is. Yeah. So you'll be able to there are documentation already published. If you go to docs.streamnative.io, you'll actually see a lot more details there. There's a particular section for private preview, and there you'll find a section for private cloud. So there, I think again, the experience will be very similar of how you enable Lakehouse storage, how you offload data to your choice of storage, but you have a lot more kind of control and flexibility because you're self-managing a good part of it, right? And you're doing it yourself. So to short answer is yes, and then we already have a lot of information published on it on docs.streamnative.io.
Thank you. Seems like there's a lot of interest on the Lakehouse storage side. There's one more question. How can users enable Lakehouse storage support in StreamNative Cloud Console?
Yeah, absolutely. So I think as we're going from private preview to public preview, we are going to soon roll out the capability, the self-service capability. Like all this while, I think we've been kind of enabling this for the customer because we're more on private preview. But I think the way we see this as a GA feature is basically within the user experience within the console, you'll basically have a little radio button kind of thing, which is just turn on and toggle it to enable it. And that's where you should see the options also to choose the type of Lakehouse you want to enable, whether you want to do it for Delta Lake or Iceberg and things like that. So it should be a very simple toggle switch type of UI. We don't have it yet, but it should come soon, within a month or so. Yeah.
Okay. One last question. This is around connectivity. With unified connectivity support, can users upload in-house built custom connectors to StreamNative Cloud?
Yes, they can. Yeah, absolutely. So I think you'll be able to basically choose your, again, I think to come back to the story itself, like, we will have a bunch of built-in connectors, which you'll find in the catalog as you come in, and we'll try to grow that list as much as we can. And then we'll also be working with a lot of ISVs. So you can, on a long term, see a lot of partner connectors show up in our catalog, which you can use. And then this is the third category, which is, the connectors which are built in-house. Usually that's a smaller category, but I think some companies really need it, as somebody's asking here, right? So yes, the answer is yes, you can very much upload either a Pulsar IO based plugin or a Kafka Connect based plugin within StreamNative Cloud and create, connectors based on that. Yeah.
Okay. Talking about connectors, there's one more question around it. What is the difference between the Unicon product and Function Mesh?
So I think Unicon is like an experience we're aiming to deliver where it's catered more towards end-to-end streaming data pipelines and all the needs around it, right? So when you think about any data pipeline, you basically think of all these different stages. How do you come in, discover, and find all sorts of sources you need? How do we basically help the users quickly get them up and running with a pipeline so they can get the data flowing very quickly? So I think right now, as where we stand, we have different components, which are, we have connectors, we have functions for lightweight data processing. I think on longer term, the way we are thinking about Unicon is we are consolidating a few things and adding a new missing feature. So we are consolidating the whole user experience to be a single user experience for Pulsar and Kafka-based connectors, right? So that's what will be new in Unicon. Right now, it's purely Pulsar-based. The second thing is that, yeah, the Kafka Connect capability. So again, going back to the story, which Karan was talking about, in the beginning of the year, we launched Kafka compatibility. We want to make sure that we deliver on that vision in a complete way. And we think through all the things our users will need to be successful with their Kafka workloads. So Kafka Connect is an important piece of that. It allows customers to bring in Kafka-based connectors. So we're bringing in Kafka Connect, and also we are using what we have, other connectivity options we have today, and combining them to offer this experience called Unicorn, which will basically help you build your pipelines and get them running very quickly. So that's the vision behind it. And there's some new components in it, like Kafka Connect.
Okay. So good number of questions. Thank you, Kundan, Dustin. This is great. And thank you all for participating, asking a lot of good questions, makes us think through a few things. Remember that you can try the StreamNative platform today. Go to streamnative.io and take advantage of the $200 credit. You can spin up clusters and you can try your use cases there. Feel free to also reach out to us if you have further questions. Remember that this webinar was recorded and we are going to share the recording with you very soon. So thank you all and have a great rest of the day.